All right, so we have our divisor of 3, our dividend of 1379, and our answer is going to be the quotient. So when we do this, we look at the 13, and we say, how many times does 4 go into 13? Because 4 won't go into 1. It goes in 3 times. Multiply that, we get 12. What do I do with those numbers? Subtract them. I get 1. I bring down the 7 and the 9. 4 won't go into 1, but it'll go into 17. It goes into 17 4 times. 4 times 4 is 16. Subtract. Get a 1, bring down the 9. 4 goes into 19 again 4 times, bringing us 16. Subtract, I get 3, right? I'm going to carry it over here. But that's the remainder, but I'm not going to have a remainder, so I put a 0.0. Okay, bring down that 0. 4 goes into 30 7 times, right? That's 28. Subtract those, I get, 7 times. That's 2. Bring down another 0. 4 goes into 25 times. So 344.75, or 344 3/4 would be the correct answer. So by the way, you know that remainder of 3 that you guys had was a remainder of 3? That would have been a remainder of 3/4, 344 3/4 if you were to write it like that. That's the same number. Right? 3/4 is 0.75. If you were struggling with that and it makes a little bit more sense now, take a second to try this one. All right, anyone have an answer for the second one? What did you get? 4,000? 1,000, yeah. 310.5. Or you had 1,310 and a remainder of 6, right? Was it a remainder of 6? And isn't 6 twelfths 0.5? There we go. It's 1/2, 0.5. All right, so on here we see that when we're dividing a problem like this, the number that we're dividing is called the dividend. The divisor is what we're dividing out of it. And then the answer is the quotient. Okay? And we can have a remainder. We'll deal with that in a minute. We're going to be doing some that don't have a remainder. You already know this because you were building polynomial functions, but factors are numbers you can multiply together to get another number. When dividing factors have a remainder of 0. It should say of 0, not or. But polynomials must be in standard form in order to divide. Exponents go from highest to lowest. If you have a missing term, you have to fill it in as 0. You guys probably remember that from Algebra 2. So in our first example, we are asked to factor this completely if using long division if it is a factor. So we're going to try to divide this, and then if anything's left that we can factor, we need to finish factoring it and write out the factors just as though we would be building a polynomial function. All right, so we have this, and they don't want us to factor it. They want us to use long division. So they're asking, is 2x minus 5 a factor first? And if it is, then factor the rest of it completely. So my divisor is 2x minus 5. My dividend is 6x cubed plus 17x squared minus 104x plus 60. Just like I did above where we said, hey, how many times is 4 going to 1? Oh, wait, let's make that 13. We don't look at the whole number at once because most people in their head don't have this memorized. They don't know how many times 4 goes into 1379. We focus on the first numbers. So just like that, we're going to focus on this 6x cubed and this first term, 2x. Now, this only works if they're both in standard form. 2x times what will give us 6x cubed? 2x times 3x squared. Or you could actually write it out if you want. You could do 6x cubed divided by 2x. That's 3. That's 2. 3x squared. You can get it that way too. I prefer to think of it as what multiplies to this. Because in the end, I'm going to be multiplying it anyhow. I have to distribute this to both of these terms in the divisor, giving me 6x cubed minus 15x squared. Now, what was the next step when we did long division with numbers? Subtract them, right? But when we have variable expressions, people get them messed up all the time. They subtract wrong, they accidentally add, they do all kinds of things. Now, sometimes I'll have one or two people in a class who consistently get it right by subtracting. That's rarely the case. So after you have figured out what the first term is and distributed, you're going to change the signs. Change the signs. Because then we can just add vertically. So I am changing the signs and adding vertically. That is how we recommend that you do it so you don't make a mistake. A lot of people will really mess up when they try to subtract those. So change the signs and combine like terms vertically. Then I'm not thinking about subtraction. I'm just combining terms. 6 and negative 6 is 0. 17 and 15 is 32. Bring down the rest of your terms. Any questions so far? Then I just keep repeating this process. The term that I'm focused on is this first one right here, and the first term of my divisor, the 2x. 2x times what is 32x squared? 16x. So I'm going to distribute the 16x. That gives me 32x squared. Distribute it to the negative 5. That gives me negative 80. Yes, negative 80 x. Now I'm going to change the signs on every term and just combine them vertically. So this one goes to 0. This one is negative 24x. Bring down my 60. Focusing just on this first term, 2x times negative 12 would give me negative 24x. So I'm going to distribute that negative 12, giving me negative 24x. I want to get the same thing here. Negative 12 times 5 is positive 60. And that worked out well because when I change the sign and combine these, I'm going to get 0 for my remainder. If I get 0 for my remainder, what does it mean about the 2x minus 5? It is a factor, not just a divisor, but actually a factor. So right now in factored form, I have 2x minus 5 times 3x squared plus 16x minus 12. That is our original dividend, but I've factored this out, and so the dividend is written as the product, this times this. Just as if I were to divide 6, where is it? 6 divided by 3 is 2, because 2 times 3 is 6. Okay, those are factors of 6. Now, have I factored completely, though? What else can I do? Break down the quadratic that remains. If I can't, if I think I can't, I need to check by what? What would tell me if it's not factorable? Starts with the D. The discriminant. So if I'm like, I can't find the factors, I don't know if it's factorable, I'll find the discriminant, and that'll tell me if it actually is or not. But I'm pretty sure it is, so I'm going to just try it first. 3x times x is the 3x squared. I needed to get to 16. I've got 4 and 12, or 6, actually. No, I need to get to 16. Yes, 6 and 2, because that would be 18, and minus 2 is 16, and they would multiply to negative 12. So I have those two factors from the quadratic, and this original factor that we divided out with long division. Now this has been completely factored. Those are all the factors of 6x cubed plus 17x squared minus 104x plus 60. All right, give this a try for the next problem. See if you can get the right answer for the next problem. problem, your dividend is 6x cubed plus x squared minus 17x, or 117x plus 140. And your divisor is 3x minus 4. We want to see if that's a factor. Anyone have an answer for us? How about 2x squared? Did you guys get that? Because that gives you the 6x cubed when you distribute minus 6x squared. Or no, minus 8x squared, right? And then you change the sign and combine them. That gives us 9x squared minus 117x plus 140. And then your next term should be positive 3x. Is that what you guys got? Because that distributes to give us the 9x squared that we're looking for, minus 12x. When we change the sign and bring them down, we get, what is that? What is it? Negative 105, thank you. And then I bring down the 140. To get 105 from 3, or what times 105 is 3? 35, right? So minus 35, because that will multiply to negative 105x. Then this is negative 140, actually positive 140, because negative times negative. 150, oh, it was 140, sorry. This was the 140, sorry. When I change the sign on the bottom, I get a remainder of 0, which means that this is a factor. It's our first factor of this dividend. Did you need something, Mr.? Yeah, okay. So this is 3x minus 4. And what remains is a quadratic that can also be factored. Did anyone finish this problem by factoring that? Yes, sir. Donnie, what's our factors? X plus 5. So that multiplies to negative 35, and then the middle will have 10 minus 7, which is 3. Perfect. And so there are our 3 factors. All right, we're going to go on to the next page where we look at some who are not going to be factors. So yay, we won't have to factor them completely, but we do have to do something different. This little box right here talks about something that I'm going to simplify for you in a numerical example. What is 7 divided by 3? It goes in how many times? Somebody said 2.5. Oh my goodness. Okay. How many times does 3 go into 7? 2, right? Because 2 times 3 is 6. So how many am I off by? I'm off by 1, right? So do I say 2 remainder 1? No, we did that in elementary school when we were learning long division, or when we were learning division. We don't say 2 remainder 1. We say 2 and what? 1/3. Notice it's our remainder over our divisor. That's like 2 plus 1/3 is 2 and 1/3. That's what that means. So this is our quotient is this part plus the remainder over the divisor. So at the end, if we have a remainder, we have to add it over the divisor as part of our quotient. That's if it's not a factor and doesn't go in evenly. All right. So for this next one right here, we're going to write our divisor and put our dividend. Go ahead and divide that and see if you can get the right answer. If it is a remainder of 0, we're going to factor completely. If it's not, see if you can write your answer like we did with the numerical example. All right, so if we do this correctly, you should have gotten 3x squared minus x plus 4 with a remainder of 10. And so how do I write that at the end? Plus what? 10 over the divisor of 2x minus 1. This is the quotient right here. in blue at the top of the page. So because it didn't go in evenly, I have to put plus the remainder over the divisor. Now, if that had been a negative 10, then I could put plus negative 10 over 2x minus 1, or I could put minus 10 over 2x minus 1 if it had been a negative 10. You get to decide if you want to do that. All right, we're going to move on to example 3, where we have a polynomial of degree 2 or higher. You should have done this in algebra 2 as well. It's not that bad. We're just focusing again on the first terms. So with this one, we're going to put our dividend here. Again, if you have any terms missing, you need to put a 0 in place of them. There are none missing for this one. If you don't do that, it'll screw you up. And then the same thing here for our divisor. We have x squared, so we should expect a term x and then a constant after it. So I've got x squared minus 5x plus 6. And again, I'm just going to focus on the first terms. X squared times x would give us the x cubed. But I have to distribute it to all three of those in the divisor. So that's minus 5x squared and plus 6x. I'm going to go through and change the sign on all of those. That gets rid of the x cubed. I now have 4x squared minus 20x plus 4. Looking at just the first terms again, x squared gets to 4x squared by multiplying by positive 4. So that gives me 4x squared minus 20x plus 24. Change the sign on all of them. That's gone, that's gone. We have a remainder of negative 20. I'm going to write this as plus negative 20 over the divisor x squared minus 5x plus 6. You could write it as minus 20 over that divisor if you wanted to. Any questions about doing this with a higher degree polynomial? Right, this is mostly a review from algebra 2, right? Okay. All right, let's take a look at one other thing that actually some people don't like, but it should be faster and even more efficient than this. That's why they came up with it. Synthetic division. It's a shortcut. Why is it a shortcut? I'm just doing a repetitive process. I don't have to think about variables except in the beginning and then at the end again. Now, synthetic only works for linear divisors, like x minus a or bx minus a. Now, remember how before when we did this, when we did regular long division, we had to change the sign and combine? I don't even have to think about that because instead of dividing by this and then changing the sign, I'm actually changing the sign when I solve for this. X minus a equals 0. Okay, if that's a factor, then x would equal a. Okay? And if this is a factor, bx minus a equals 0, then I add a to both sides. Bx equals a, divide by b, x equals a over b. That would be the number I would put in my box for synthetic division. Yes, sir?
I remember last year we did it with polynomials as well, but it takes 2 steps.
It's more involved than just this, yes. Yep. So the way that we're doing it, you can't do with, we'd have to adapt it.
Okay, so
For right now, we're only doing it with linear factors. All right, so synthetic division, we have x minus 3. So that means that x equals 3 would be the answer to that factor if I set that factor equal to 0. I'm going to put that number in this box. And this, again, should be reviewed for you from Algebra 2. We have to make certain, even when we did long division, but we'd get hung up in long division if we didn't make certain, that all of the terms are there. If we've got a 5th degree polynomial, I should see x to the 4th, x cubed, x squared, x, and a constant. If any of those are missing, even the constant, I have to put a 0 in place of them. And we're taking just their lead coefficient with its sign, not lead, just the coefficient on each of those with its sign. So 2, -4, -3, -6, -5, -8. 5, 4, 3, 2, 1, 0. Does anyone remember what I do next? The first step is to bring down that first coefficient, the 2. And this is, now the rest of the process is simply multiplication and addition. Multiply what's in the box by what just got brought down and put that here. So that's going to be 6. And then add them vertically. That's going to give me another 2. Multiply what's in the box by what's down here. That's another 6. Add them vertically. That's a 3. Once you get the process down, it should go real quick. It's multiplying and combining, multiplying and combining. 3 by 3 is 9. Combining those two gives me 3. 3 by 3 is 9. Combining those two gives me 4. 3 by 4 is 12. Combining those two gives me 4. Any questions on where the numbers came from? All right, so when we're done, so remember I told you we didn't have to think about the variables or like, hey, do I need to multiply by an x squared or an x to the 4th or any of that stuff. We only had to think about it in the beginning to make sure all the terms were there. And now we have to think about it at the end. This number on the far right will be your remainder. Then your constant, then x, x squared, x cubed, x to the 4th going up. Remainder, then our constant, which doesn't have a variable, x to the 1st, x to the 2nd, x to the 3rd, x to the 4th, and so on going to the left. By the way, this was a 5th degree polynomial, and we were dividing by a linear factor, so we expect to get a 4th degree polynomial, since we're only pulling one factor out. So this is 2x to the 4th plus 2x cubed plus 3x squared plus 3x plus 4 plus the remainder over the divisor, 4 over x minus 3. Any questions on that? All right, for our next example, we again have a linear factor, but it's not just x minus or x plus the number. It is 4x plus 1. And so when I solve that, I'm going to have to subtract 1 and divide by 4. So x is -1/4. I'm going to double check that I have all my terms. It looks like we do 4, 3, 2, 1, 0, so that's good. So in the box, I put in my -1/4. I have 8, 38, 5, 3, and 3, and I again check 4, 3, 2, 1, 0. Some people are like, oh great, now I have to multiply by a fraction. Well, this fraction is not so bad. Multiplying by -1/4 is really like doing what? Dividing by -4 in this case, yep. So we're going to bring down the 8. That's the first step, to bring down the first coefficient. And I'm just going to divide it by -4, because that's the same as multiplying by -1/4. Dividing by -4 gives me -2. Add them vertically, 36. 36 divided by -4, -9. Add them vertically, -4. Divided by -4 is +1. Add them. Divide by -4 is -1. Add them, gives me 2. And I'm done. As long as this was my constant term, I'm done here. 2 is my what? Remainder. And then this is constant x, x squared, x cubed. So my answer is 8x cubed plus 36x squared minus 4x plus 4 plus 2 over my divisor of 4x plus 1. And you couldn't see that. There it is. All right, any questions on that? At this point, I mean, most of this should be reviewed to you. You're going to say, can I perform synthetic division? This should have helped brush you up so you're not as rusty on that. Can I perform long division? Your assignment are these pages right here. This concludes the notes for lesson 2.3, day 1.